Welcome back to part 4 of our DIY autonomous mobile robot building series. If you missed any of parts 1, 2 or 3, catch up with the links in the video description below or access the link to the playlist at the end of this video. Today we're delving into the exciting phase of the operational testing of our newly soldered circuit. In this video we'll connect the following components: the modified 360 degree servo motors, the SG90 micro servo, and the HC-SR04 ultrasonic sensor, which will all be plugged into our circuit. With our circuit board here, we have these wires soldered onto the underside of the perf board. So I feel that it would be best to temporarily mount the perf board so that the wires are physically protected when we insert the jumper wires onto the various header pins. So I decided to use this HDPE chopping board as the material for our mounts. HDPE, which stands for high density polyethylene, is also ideal for building a robot chassis because it is very easy to cut, drill or file. In fact, you can use an ordinary cutter knife to cut HDPE, and you can screw self-tapping screws into it as well. The only disadvantage is that glue usually doesn't stick well to HDPE. Later on in another video, I'll be using HDPE to construct the robot chassis and to mount the perf board onto the chassis. Because I'm using a cutter knife, I thought I would utilize this opening so I won't have as much to cut out. It turns out to be quite an interesting looking shape, but it will do the job just fine. In fact, since we'll be using self-tapping screws, it is more convenient to have at least 2 self-tapping screws screwed into a single integral piece of HDPE to help prevent the HDPE mounts from rotating with the screws. To help get the self-tapping screws started, I'll just use this all-tip screwdriver and then screw in the self-tapping screw, and I'll do the same for the other 3. So there we have the perf board mounted so that the wires on the underside are a little more protected. Now let's establish the connections between our components and the Arduino. We'll also need to attach a 2-pin female DuPont connector for the positive and negative wires that come out of the battery pack, so I'll just do that now. If you need guidance on how to create your DuPont connectors for wires, such as from the battery pack or for creating your own jumper wires, check out the link provided at the end of this video. These are the jumper leads that I'll be using to connect the Arduino to the perf board and also to connect the servos and the ultrasonic sensor to the perf board. We will wire up the components based on this diagram, which shows the circuit that was designed in part 2 of this series. However, even though the header pins are also shown for convenience, this diagram is based on the underside of the perf board. Currently, the underside of the perf board looks more like this, except that the headers themselves aren't actually visible. So we'll flip the perf board over and also change the orientation of the diagram to be consistent with the video footage. We are starting with just the header pins showing on the top side, with the red and black wires not shown because they are on the underside. First we'll plug in the left and right servos, which are high-tech HS311 servos that have been modified for 360 degree continuous rotation. I have a separate video showing how to modify these servos. Check the link at the end of this video if you haven't seen it yet. We have the ground, positive and signal wires connected to the middle 3 pins of the 5-pin header for the left servo, and then likewise with the right servo, plug the connector into the 3 middle pins of the 5-pin header for the right servo in the exact same orientation, with the ground, positive and signal wires in the same order as for the left servo. Next we'll attach the battery pack. Make sure you have the battery pack switched off initially. The battery pack indicated in the diagram shows AAA batteries, when in fact we'll be using 4 AA sized 1.2 volt rechargeable batteries. We'll just place the Arduino to the side like this for testing purposes. Next we'll connect the SG90 micro servo. In this particular servo, the ground is brown instead of black and the signal wire is orange instead of yellow. Then the last component we'll connect to the perf board is the HC-SR04 ultrasonic sensor. Now let's connect the jumper wires to the Arduino. Connect a black jumper wire from the ground pin on the header pin of the left servo to ground on the Arduino. Connect a yellow jumper wire from the header for the left servo to analog pin number 10 on the Arduino. Connect another yellow jumper wire from the header for the SG90 micro servo to analog pin number 11 on the Arduino. Connect another yellow jumper wire from the header for the right servo to analog pin number 9 on the Arduino. Next we have the blue and green jumper wires which share the same female DuPont connector but have separate male DuPont connectors. Connect the blue jumper wire from the header pin that is for the echo pin to pin number 7 on the Arduino. Connect a green jumper wire from the header pin connected to the trig pin to pin number 4 on the Arduino. Connect another black jumper wire from the ground pin on the header pin of the right servo to another ground on the Arduino. Lastly, connect another black jumper wire from the ground pin on the header pin, to which the battery pack is also connected, to another ground on the Arduino. Let's move on to the operational testing phase. We'll use Arduino code to execute tests on each component to ensure that each component operates as intended. Please click on this link to continue on to part 5, which is already uploaded.